Hi there, Mr. Sutton here with the AB Calculus 515 Extra Practice Number 1 Solutions on Integration by Substitution with Definite Integrals. For this first problem, we're trying to find the indefinite integral, just to make sure you're paying attention, of this expression here. Now, there's no way to really expand this and multiply by x squared, so we're going to have to use substitution instead, because we have an inner function here whose derivative is elsewhere in the integrand. So I'm going to let u equal x cubed minus 1, then du equals 3x squared dx. Divide both sides by 3x squared to get dx alone. And since this is an indefinite integral, I don't have to worry about u values anywhere. I'm just going to plug everything back in. So I've got x squared times u to the 10th times du over 3x squared. The x squareds are canceling. I've got 1/3 u to the 10th du. And then I can bump this up to the 11th power. Dividing by 11, I've got 1 over 33 u to the 11th plus c. And then all the answer choices you'll notice are in terms of x. So whereas if this were a definite integral, we would probably just keep it in terms of u. Since the answers are in terms of x, we're going to substitute the x cubed minus 1 back in for u to write 1 over 33 x cubed minus 1 quantity to the 11th plus c. And then that's going to give us answer choice, choose carefully here, looks like D. On this problem, I want the integral from 0 to 4 of this expression. Since I have an inner function here whose derivative is somewhere else in the problem, I'm going to try substitution first. So I'm going to let u equal x squared plus 9. So then du equals 2x dx. And dx, I can actually replace that with du over 2x at some point. But first I need to get my x values here and turn them into u values. So if x is 0, then u is going to be 0 squared plus 9, or just 9. And if x is 4, then I have 4 squared plus 9, which is 25. So then this is really the integral from 9 to 25 of x over square root of u times du over 2x. All right, let's clean this up a little bit. X's can cancel. I'm going to have 1/2 times u to the negative 1/2. I'll write it that way so that I can use my reverse power rule a little bit more easily. So this exponent then is going to bump up to positive 1/2, and then we're going to multiply by the reciprocal of that, 2. 2 times the 1/2 here is going to cancel out. So when the dust settles, I've just got u to the 1/2 integrated, or evaluated rather, from 9 to 25. So that's just the square root of u then, u to the 1/2. So I've just got the square root of 25 minus the square root of 9. 5 minus 3 gives us 2. Choice D. For this problem, I want the integral from 0 to 2 of this crazy expression. Since I have this inner function whose derivative is over here essentially, I'm going to try u substitution first. So let's let u equal x cubed plus 1. So then du is 3x squared dx. And I can rewrite this as du over 3x squared equals dx. Next, these x values have to become u values for me to replace all these things. So if x is 0, u is going to be 0 cubed plus 1, so 1. If x is 2, then u becomes 2 cubed plus 1. 8 plus 1 is 9. So then I have the integral from 1 to 9 of u to the 1/2 power times x squared du over 3x squared. And then these x squareds are going to cancel, so that's 1/3 u to the 1/2. Now I have to use my reverse power rule. This bumps up to 3/2, which means we're multiplying by 2/3. That's going to be 2 over 9 u to the 3/2, evaluated from 1 to 9. So I've got this 2/9 that I'm just going to multiply by the stuff that's getting subtracted. And inside my parentheses getting subtracted now, I have 9 to the 3/2, which is the square root of 9 cubed. Next I have 1 to the 3/2, so that's the square root of 1 cubed, and I'm subtracting that. Crunching the numbers here, this is going to be square root of 9 3 3 cubed is 27. We've essentially got 27 minus 1. So that's 26 inside there. And multiplying that by 2/9 to get an answer choice, that's going to be 52 over 9, which is one of the answer choices, choice A. For this problem, we're trying to figure out the integral from pi over 4 to pi over 2 of cosine over sine. Now, the intuition on this, you might be thinking, well, I'm just going to simplify this to cotan, but we don't know the antiderivative of cotan, or at least I don't. It's not one of those that you're supposed to memorize. So we're going to try a different tactic here. The key on this one is recognizing that cosine and sine are derivatives of each other. So that means that we can use u substitution on this one. I'm going to let u equal sine of x. I had to make a choice here, but I'm going to let it equal sine of x, and you'll see why this is really the only way it's going to work in just a moment. So if u is sine of x, du is going to be cosine of x dx. And then getting dx by itself, I've got du over cosine of x. So this is why I had to let u equal sine of x rather than cosine of x. If I do it this way, I end up with a cosine in the denominator, which is going to end up canceling the cosine in the numerator. If I had let cosine be my u value, I would have ended up with a sine in the denominator, which would not help me out. All right, now I do need to still turn the x values into u values. So if x is pi over 4, u is going to be the sine of pi over 4, which is root 2 over 2. And if x is this 1, or pi over 2 up here, u is the sine of pi over 2, which is going to be just 1. Plugging it all in, we've got the integral from root 2 over 2 to 1 of cosine over u, and then du over cosine of x. Cosines cancel, so this is just 1 over u du. And the antiderivative of that is ln of absolute value of u, which we're now going to evaluate from root 2 over 2 to 1. Plugging stuff in, I've got ln of 1 minus ln of root 2 over 2. And I can drop the absolute value because these are both positive values to begin with. What is the ln of 1? Well, that's 0. I mean, you'll notice all the answer choices have a single ln in it, and this is why. ln of 1 is just 0. So this is negative ln of root 2 over 2. Unfortunately, that doesn't match any of the answer choices. Now, the key on this is recognizing that none of the answer choices have a negative ln in them. So if there is a negative, what happened to it? Well, this is really like having a negative 1, which, since it's in front of a logarithm, we can pop that in here as an exponent on the root 2 over 2. Kind of sneaky, but that's what we have to do here to match an answer choice. So this really means the reciprocal of root 2 over 2, which is 2 over root 2. And if you do 2 over root 2 and simplify by multiplying by root 2 over itself, you end up with 2 root 2 over 2, and the 2's cancel, leaving you with just a root 2 inside the ln. Another way of thinking about this is, I mean, if you have essentially 2 divided by radical 2, you're essentially dividing root 2 squared by root 2, which leaves you with a root 2. Any way you slice it, this is going to be answer choice A. On this problem, I want the integral from 0 to 1 of this mess. So this one, I mean, it looks kind of nasty, but they're really just kind of beating you over the head with the fact that you need substitution here. I mean, we have this inner function x squared plus 2x, and then we have this x plus 1 over here. There's got to be some way that these kind of get together and cancel. So let's let u then equal x squared plus 2x, which means du is 2x plus 2, the whole thing times dx. And then dx is going to be du over this stuff. So now I also need to get some x values turned into u values. If x is 0, then u is going to be 0 squared plus 2 times 0, so also 0. If x is 1, then I've got 1 squared plus 2 times 1, which is 3. So this then becomes the integral from 0 to 3 of x plus 1 e to the u times du over 2x plus 2. Now 2x plus 2, I already kind of factored it here. This is really 2 parentheses x plus 1 if you want it to be. So these x plus 1s that I now see can cancel. and we have 1/2 times e to the u du. So that's just going to be 1/2 e to the u, evaluated from 0 to 3. So this is going to be 1/2 times e to the third minus e to the 0. Well, can't really do a whole lot with e to the third. E to the 0, we can turn that into 1. And then if I'm multiplying by half, it's really like dividing by 2. So this is e cubed minus 1 over 2, if I want to match one of the answer choices, and that's going to match choice B. For this problem, using the substitution u equals x squared minus 3, this expression is equal to which of the following? So they were awfully nice on this one. They told you what u equals. So if u equals that, then let's just go ahead and do the rest of u substitution here. So derivative, we've got du equals 2x dx. And then we have dx equals du over that 2x that we just found. Next, my limits of integration are both x values right now. I have to turn them into u values. If x is negative 1, then u is going to be, let's see, negative 1 squared minus 3. That's 1 minus 3, which is negative 2. If x is 4, then u is going to be 4 squared minus 3. 16 minus 3 is 13. So I have the integral from negative 2 to 13 of x times u to the 5th, and then I have a du over 2x. X's cancel. This is 1/2 u to the 5th du. And if I look at my answer choices now, because we didn't actually have to integrate it, we just had to convert it here. 1/2 and an integral from negative 2 to 13 u to the 5th, that's all going to be choice C. On this problem, I want the integral from 0 to 8 of dx over radical 1 plus x. Now this is a problem where you don't actually need substitution to do it. Because we have a linear inner function, we could actually use our shortcut of dividing by the tail to figure out this integral without any kind of fancy substitution. But I'm going to show you a substitution approach just so we get a little practice with it. So I'm going to let u equal 1 plus x. I mean, there's no other inner function here to mess with. Then du is going to equal dx. So then, if those are both the same, I just need to get my u values now out of the x values. If x is 0, u is 1 plus that, so 1. And if x is 8, u is going to be 9. So then I'll just write this as the integral from 1 to 9 of essentially du over square root of u. So then this is really u to the negative 1/2 power. And using my reverse power rule, this bumps up to a power of 1/2. Multiplying by the reciprocal of that, I've got 2 u to the 1/2, or 2 radical u. Integrating that from, or evaluating that from 1 to 9, I've got 2 times square root of 9 minus square root of 1. This is 2 times 3 minus 1, 2 times 2, which comes out to 4. Choice D. On this problem, I'm trying to find the definite integral from 0 to 5 of this expression. So I notice here I have an inner function whose derivative is out here essentially. So I'm going to let u equal 25 minus x squared. I'm going to use u substitution on this. So du then equals negative 2x dx, and dx itself equals du over negative 2x. Swapping my x values out for u values, if x is 0, u is 25 minus 0 squared, which is 25. If x is 5, u is 25 minus 5 squared, which is 0. So this one is a little bit tricky, but I actually have a lower limit of integration that becomes higher when I turn it into a u value. So this is going to be the integral from 25 to 0 of u times radical u, or rather x times radical u, and then we have a du over negative 2x. All right, so these x's are canceling. This is going to be negative 1/2 times u to the 1/2 power. And then, let's see here, antiderivative for that, this bumps up to a 3/2, so I'm multiplying by 2/3. So negative 1/2 times 2/3, That's going to become 1/3. And then let's see here. I'm going to take out my negative 1/3. And if I'm doing the 3/2 power, I'm going to be essentially square rooting 0 and then cubing it, which gives me 0. And then I have to do the same with 25, so square root of 25 cubed, getting subtracted there. So this is negative 1/3 times, well, let's see here. This is 5 cubed 125. So negative 1/3 times negative 125, which comes out to positive 125 over 3. For this problem, I want the integral from 2 to 4 of dx over 5 minus 3x. Now, this is one where you actually do not need to use u substitution at all. We could just call this ln of absolute value 5 minus 3x and divide by a tail of negative 3. So multiply by negative 1/3. And that would solve the problem eventually. But I'm going to use substitution just so we get a little bit of practice with the technique on this extra practice. So I'm going to let u equal 5 minus 3x. There's not a whole lot of other options on this. So we then end up with du equals negative 3 dx. So dx equals du over negative 3. Now I'm going to get some u values out of my x values here. If x is 2, then u is 5 minus 3 times 2, or negative 1. If x is 4, u is going to be 5 minus 3 times 4, so that's 5 minus 12, which is negative 7. So I've got the integral then from negative 1 to negative 7 of essentially du over negative 3, and we have a u as well in the bottom there. So this is going to be negative 1/3 ln of absolute value of u when we take that antiderivative. And I'm doing that from negative 1 to negative 7. Now when I do this, so I've got this negative 1/3 that's I'm just going to pull out here. But inside getting subtracted, I've got ln of absolute value of negative 7, which I'm just going to write as ln of 7. And I also have ln of absolute value of negative 1, which I'm just going to write as ln of 1 because we're absolute valuing it. I can go a little bit further here. ln of 1 is 0, so this is just negative 1/3 times ln of 7, or negative ln of 7 over 3, which gives us choice B.